Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 7, Markup and Markdown Problems. Classwork Example 1, a video game markup. Games Galore Superstore buys the latest video games at a wholesale price of $30. You guys don't watch or play video games, do you? Nah, I didn't think so. The markup rate at Games Galore Superstore is 40%. Okay, so there's a wholesale price of $30 and a markup of 40%. So they pay $30 for a video game. So let's just say they EA Sports. Let's say they purchase directly from EA Sports and they buy the new Madden 2019 game or something like that. They're going to pay $30 for it. They then mark it up 40% and sell it to the general public, including you, for this amount. Everybody's in business to make money, and there's also expenses in business such as rent and utilities and taxes and. So they need to make money. A says, write an equation to find the price of the game at the Games Galore Superstore and explain your equation. So we want to represent variables. So let's let P equal price of game. P is the price. W will be the wholesale price. That's the cost they paid. And then we have percentages. So we have an equation that says Q equals percent times the whole. And that's quantity. Quantity equals percent times whole. We've been doing this now for several lessons. If you've been watching this video series, you know what I mean by Q and percent and whole. In this case, what we want to find is the price of the video game. So our quantity in this case is going to change to P. Our percent is the video game store is going to pay an amount of 100%, plus they're going to add 40% to that cost. So the percent is going to be 100% plus 40%, and the wholesale price was $30. So there's our equation. Okay, so this would simplify to P equals 140% times 30. So now it says to solve the equation from part A. So I'm going to rewrite P 140% times 30. (140% written as a decimal is 1.4. So 1.4 times 30. So P equals, I forgot my equal signs here. P equals 140% times 30. There should be an equal sign there as well. P equals 1.4 times 30. P equals, well, I have a 0. 3 times 4 is 12. Carry the 1. 3 times 1 is 3 plus 1 is 4. And there's one decimal place. So since this is money, we want to show the decimal place going out 2 even though it's zeros. So the price of the video game is $42. So they paid $30 for it. They sold it to you for $42. They profited $12. What is the total markup of the video game? Well, you take your $42 that we just mentioned, what they sold it to you for, subtract the cost of the video game, which is $30, and they paid, or their total markup of the video game was $12. D says, you and your friend are discussing markup rate. He says that an easier way to find the total markup is by multiplying the wholesale price of $30 by 40%. Do you agree with him? Why or why not? Well, if he's going to say the cost is going to be P equals 30 times 40%, which is 0.4, then P would equal 12, because 4 times 30 is 120, and there's one decimal place. So it would be $12. So I would say yes, I agree. Why or why not? Because it came up with the same amount, 12 bucks. So he'd simply say, well, just multiply 30 times 40%. We know how much they're going to mark it up. Add that to the original cost, and it would be 30 plus 12, which is also $42. Example 2, Black Friday. A $300 mountain bike is discounted by 30% and then discounted an additional 10% for shoppers who arrive before 5 a.m. So if any of you have ever been out the day before or the day after Thanksgiving, Friday is usually the day after Thanksgiving. The Friday after Thanksgiving is Black Friday. Find the sales price of the bicycle. So what we want to do here is assign a variable. So we're going to let D equal discounted price. Okay. So we use the equation, the quantity equals a percent times a whole. And our quantity we're looking for is our discounted price. And the percent is 30%, but we're discounting it. So we're going to take 100% of the cost of the bicycle and subtract 30% and multiply it by the whole price, which is $300. So there's our equation. So this simplifies to 70% times 300, which converts to a decimal of 0.7 times 300. So therefore our discounted price is 0.7 times 3. 7 times 3 is 21. Carry the 2 zeros and I have a decimal place of 1. So I move it to the 1 and then I just add a 0 because it's money. And the discounted price will be $210. So if we get a 30% discount on $300, we're going to pay $210 for the bike. In all, by how much has the bicycle been discounted in dollars? Explain. Well, you take the original price, which is the whole price, minus the discounted price, and that equals the sales price. So the whole price was $300. Actually, that wouldn't be the sale price, that'd be the discount. So the whole price minus the discounted price equals the amount of money that we saved the discount. And do we want to use a different variable for that? How about just X? Okay, so 300 minus 210 equals X. 90 equals X. So $90 was the discount. Don't confuse discount with discounted price. C, after both discounts were taken, what was the total percent discount? Okay, so far all we've done was taken the 30% off. So now what I need to do is go back and it says then discount an additional 10. So let's say we got there before 5 a.m. They're going to give us 30% off, which is $210. And now that is going to be our price W. So now I rewrite this equation, Q equals percent times whole. And Q is our discount price. And the percent off now is 10%. So we're going to take 100% minus minus 10%. Not minus 90, minus 10%, and multiply that by the whole price, which is now this whole price. So they've already discounted it 30% to get to 210, but we're early birds. We're there before 5 a.m., so we're going to get an additional 10% off. So that means we are going to pay 90% of $210. So convert that to a decimal, and it's 0.9 times 210. And when I multiply that, I get 9 times 0 is 0, 9 times 1 is 9, 9 times 2 is 18. There's one decimal place. We're talking money, so add another 0 there. So we are going to pay $189 for that $300 mountain bike if we get there before 5 a.m. After both discounts were taken, what was the total percent discount? Well, was it 30 plus 20 equals 40%, or was it something else? Okay, I haven't answered this question yet, though. It says, in all, by how much was the bicycle been discounted in dollars? So the original price was $300, and now it's $189. So 300 minus 189 is $111. So there's the answer to question B, $111. Okay, so now we're going to find, after both discounts were taken, what was the total percent discount. So we're going to let P be the percent of the sales price. So we're going to say part equals percent times whole again. So we have the price that we paid, $189, equals the percent P times the whole price, which was $300. In solving for P, we're going to divide both sides by 300. These 300s will cancel and we will find our percent discount. So 189 divided by 300. Hey Siri, what's 189 divided by 300? Oh, I don't have my phone with me. So I'm going to have to do it this way. 300 will not go into 189, so I need a decimal. 6 times 3 is 18. Subtract and get 900. 3 goes into 9 3 times. And there we have it. That wasn't too bad. So 0.63 is 63%. So what we want to do now is the actual final discount as a percent would be 100% minus this 63% equals 37%. Okay, so we can't just say, well, I got 30% off and 10% off, so that's a total of 40%, because 10% of 30% is less than 10% of 100%, so I can't just add them. So 30% and then additional 10% is only 37%, not 40. Part D, instead of purchasing the bike for $300, how much would you save if you bought it before 5 a.m.? Okay, how much would you save if you bought it before 5 a.m.? We already answered that question, didn't we? Exercise 1 through 3. Sarah went shopping and decided to purchase a set of bracelets for 25% off the regular price. If Sasha buys the bracelets today, she will save an additional 5%. So she got 25% off. And if she buys the bracelets today, she'll save an additional 5%. So keep in mind from the last problem, we can't just take 25 and add another 5 and say it's 30%, can we? Well, let's see. How much money will Sasha save if she buys the bracelets today? Okay, so we are going to let B, capital B, equal sale price with both discounts. Sale price with both discounts will be B. So B equals let's see. Okay, so if she is saving an additional 5%, that means she is paying 95%. So she pays 95% if she's saving 5%. And then if she saves another 25%, then she's paying 75%. So all I'm doing is taking the 100% minus these percents that she's getting off, and that's what we pay. So if you are taking a whole price and you take a 5% discount, you're paying 95%. If you take 25% discount, that means you're paying 75%. And the price of the bracelet was $44. So we're taking 95% of 75% times $44. So B equals. Okay, so I'm going to multiply 0.95 times 0.75 first. 5 times 5 is 25, carry the 2. 9 times 5 is 45, and 2 is 47. 0, 5, carry the 3, 63, and 3 is 66. Okay, 66. 5, 2, carry the 1, 1, 7, 4 decimal places. So we're going to pay 71.25%. Then we take 0.7125, multiply it by 44. 5 times 4 is 20, 4 times 2 is 8, plus 2 is 10, 4 plus 1 is 5, 7 times 4 is 28, and we're just going to shift this over 1 because it's a 4 again. 0, 0, 5, 3, 11, 3. We are going to pay $31.35. Okay. So if she buys the bracelets today, she's going to get a 71.25. 71. She's going to pay 71.25. So she's going to get 28.75% off. So 25 plus 5 is not 30% because we're only taking a percent of a percent. Number 2, a golf store purchases a set of clubs at a wholesale price of $250. Mr. Edmund learned that the clubs were marked up 200%. Is it possible to have a percent increase greater than 100%? And what is the retail price of the clubs? Okay, yes, it is possible. You can mark up a lot more than 100%. If you trade in the stock market, you can make thousands of percent when a company explodes. So we're going to let C represent the retail price. Or how about R? R equals the retail price. R is the retail price. So R is going to equal the 100%, the cost of the clubs, plus the 200% markup, times the price of the clubs, which was $250. Okay, so this golf store purchased the clubs for $250, which is this 100% times $250, and then they marked it up 200%. So R equals 100% is 1, 200% is 2, times $250. So R is going to equal 3 times $250. So therefore the retail price is going to be $750. So the store bought the clubs for $250, they marked them up 200% and sold them for $750 and profited the difference, which is $500. So 3 says, is a percent increase of a set of golf clubs from $250 to $750 the same as a markup rate of 200%? Explain. Okay, this is a lengthy explanation, so I just brought it in. Yes, it is the same. In both cases, the percent increase and the markup rate show by how much, in terms of percent, the new price is over the original. The whole is $250 and corresponds to 100%. So 750 divided by 250 is 3 over 1 times 100%, which equals 300%. 750 is 300% of 250. 300% minus 100% equals 200%. From exercise 2, the markup is 200%. So percent increase is the same as markup. Okay, example 3 is working backwards. So now we can also work backwards. A car that normally sells for $20,000 is on sale for $16,000. The sales tax is 7.5%. What percent of the original price of the car is the final price? So we're going to use our formula, Q equals percent times the whole. Okay, and the quantity in this case is the on sale price, which is 16,000. And that equals some percent, and we're going to call that P, times the original price, the whole price, which is $20,000. So if I divide both sides by the original price, these cancel, and I get P equals zeros cancel, zeros cancel, zeros cancel. Half of 16 is 8 over 10. Okay, so if I say 8 over 10, well, that means 0.8, or 80%. So the percent of the original price is the final price. So 16,000 is 80% of $20,000. B says find the discount rate. Well, all we have to do is take the original price 100%, subtract the 80% that they're paying, and the discount is 20%. Okay, part C says by law, sales tax has to be applied to the discount price. Uncle Sam needs to get his share. However, would it be better for the consumer if the 7.5% sales tax was calculated before the 20% discount was applied? Why or why not? Okay. So we can do two things. Apply tax first. Okay, we can apply the tax first, or we can apply the discount first. So we're going to do both here and see which is better. So if we apply the tax first, we would take the 100% times the 7.5%, or plus, I mean. So it's 100% plus 7.5%, and then multiply that by the original cost. Okay? All right. So we take 107.5% times 20,000. So when I do that, I get 1, 2, 3, 4 zeros. 5 times 2 is 10. 7 times 2 is 14, plus 1 is 15. 2 times 1 is 2. I have one decimal place. Plus, well, one decimal place. Let's see. It's not going to be that much. The decimal place is going to go over here. So we're going to pay $21,500. Okay. So if we apply the tax first and say, okay, $20,000 car plus the tax is going to be $21,500, and then apply the discount, which was 80%, correct? The discount was 80%, or the discount was 20%, so we're going to pay 80% of that. So I would say that 0.8, the 80% we're going to pay of $21,500 is 8 times 0, 0, 0, 5 times 8 is 40, 8 times 1 is 8, plus 4 is 12, 8 times 2 is 16, plus 1 is 17. Then we're going to pay $17,200 for the car if we apply the tax first. If we apply the discount first, I'm not going to do that again. We've already done it, haven't we? Or have we? If we applied the discount first, it was $16,000. So we're just going to add the tax to it. So what we're going to do is take the 100% plus the 7.5% times the discounted price of 16,000. So that would be 107.5% times 16,000. And that comes out to be, let's ignore these 3 zeros. 6 times 5 is 30. 6 times, well, let's do it over on the side here because it's 2 digits. 1075 times 16. So it's going to be $17,200. Okay, so since these two prices are equal, it doesn't matter if you apply the tax first or second. When you discount the tax price, or if you discount and then tax, it comes out to be the same. So now it says to write an equation applying the commutative property to support your answer to part C. Well, what you could say is $20,000 times the 1.075 you're going to pay times the 80% is going to equal $20,000 times the 80% of that times the 1.075. So all we're doing was here we multiplied the tax first and then multiplied the discount. Here we multiplied the discount in and then the tax. And there's the commutative property of multiplication. Exercise 4. Exercise means try it on your own, pause the video, and then see how you did. Okay, so exercise 4A says write an equation to determine the selling price in dollars P on an item that is originally priced S dollars after a markup of 25. So that would be P selling price equals the 1.25, 125% of the S. B says to create a table showing 5 possible pairs of solutions to the equation. Okay, so here's a table I set up, and on one side we have the price of item before the markup, S in dollars, and the price of item after the markup, P in dollars. So I have P equals 1.25S. Okay, so S is my independent variable, which is on the left, and I substitute values in. So if I put a 10 here, then it'd be 1.25 times 10, which just moves the decimal one place to the right, so that'd be $12.50. And then if I just add 10 to each, let's do 10, 20, 30, 40, and 50. 1.25 times 2 is 2.5, which would be $25. So remember, if we just double this, then this is going to double. We triple it, then it's going to just add $12.50 each time, which is now $37.50, and then 50, and then $67.50, or $62.50, adding $12.50 each time. $62.50. Okay, so there it is. So now it says create and label a graph of the equation. So now we're going to graph this. So I labeled my x-axis, price of item before markup in dollars S. So that's really my S-axis. Okay, I labeled the y-axis, price of item after markup in dollars P. So this is my P-axis instead of Y. So instead of XY, we're graphing SP. And then we need to give it some values. And I'll just write those in. So this is 0. And let's see, what do we have to go up to? 50. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Well, that'd be, let's see, 20. I could go out, hey Siri, what's 50 divided by 20?
50 divided by 20 is 2.5.
Okay, so we can make each increment 2.5, or go like this, 5, 10, 15, 20, 25, 30, 35, 40, 50, 45, and 50. So I like to fit the graph as much as possible into what we're given. And then we got all the way up to 6250, so I want to go up to at least that. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Hey Siri, what's 62.5 divided by 13?
62.5 divided by 13 is about 4.8076.
Okay, so to make this fit, I'll go by 5. So this would be 5, 10, and I'll skip and just do 20, 30, not 40, 30, 40, 50, not 15, 50, and 60. So this would be 70 at the top, and that would be far enough. Now when I graph these, I'm going to plot what I just put in my table. So when S is 10, P was 1250, which was a little more than 10. This is 15, so 1250 would be about here. 20, 25, which is right here on this corner, on this grid corner. 25 is right there. 30 would be 35, 750, would be halfway there. This would also be half. And of course, 0 is going to be 0. And 40 was $50. And 50 was $62.50. Oops, that's 60. So I just need to move that dot up to $2.50, which is right about here. All right, so if I then connect the dots, okay, whenever you're graphing, you should always be accurate. Use a ruler. Put this down at 0. Rotate it up. Extend it out. And draw my line. Okay, so there's the graph. D says interpret the point 0, 0 and 1R. Well, point 0, comma 0 means, if we go back, zero is right here. Well, P is price of item before markup. So if the price before markup is $0, then the price of the item after the markup will still be $0. So if there is no cost, there's no markup. So I'll say that. No cost, no markup. Okay. 0% of 0 is 0. And the point 1, comma R, well, what does that mean? 1, comma R, if I go back and look at my graph now, well, 1 is, here's 5, here's 2.5, 1.25 is here, so 1's about here, so I would plot the point right there on my line. So that's the point 1, comma R. And R, in this case, would be the amount if I substituted in a 1 for here, so I'm going to do that. So P equals 1.25 S. Okay, and my S was 1, because this is the point S, comma P. So if S is 1, then P equals 1.25. So my R is 1.25. So that means the point 1, comma 1.25. So if the original price was $1, the markup would be $1.25. Or it costs $1.25 after the markup of 25%. That's the unit rate. Okay? Unit rate. In other words, what does 1 unit cost? 1 unit costs $1.25. In In exercise 5, it says use the following table to calculate the markup or markdown rate. Show your work. Is the relationship between the original price and the selling price proportional or not? Explain. Okay, so here we have an original price of $1,750, a selling price of $1,400, so that's less. So this is a discount. So selling price P equals 100% minus our discount, our original price M, times the whole. So 100% of M minus the whole times the whole. So the selling price here is $1,400. And that equals 1 minus M times the whole, which was 1,750. So to solve, I'm trying to get M. I'm trying to find the M. What did I multiply this by to get that? So I'm going to divide by 1,750. These cancel, and I get 1 minus M, and 1,400 would be the same as 140 minus 175. I can reduce that by 5, a multiple of 5. 5 goes into 14 twice, 5 goes into 40 8 times, 5 goes into 17 3 times, 5 goes into 25 5 times, and I see that 7 will go into 28 4 times, and 7 will go into 35 5 times. And I have 1 minus M. Okay, so 4/5, well, if I doubled that now and said 8 over 10 equals 1 minus M, then that's 0.8 equals 1 minus M. So if I subtract 1 from both sides, I get 0.8 minus 1, which is a negative 0.2, equals negative M. Therefore, M equals 0.2. So the markdown rate is 20%. Okay, so 20% markdown of 1,750 is $1,400. Okay, so is it proportional? So that what that means is P over M has to be true for every value. So if I multiply this by 0.2, 15 times 2 is 3. Subtract 300 from 1,500, I get 1,200. Multiply this by 2, and I get 25, 250. 1,250 minus 250 is 1,000. Multiply this by 0.2, and I get 200. 1,000 minus 200 is 800. And multiply this by 0.2, and that's 150. 750 minus 150 is 600. So, is it proportional? Yes. Because P divided by M is always true, or the same. Okay, we have a constant rate of change. Okay, that is the end of lesson 7. Review the lesson summary.